Uh, hello, my name is Ryan Ashley. I'm a senior software engineer with Incutel Labs, and I'm here to talk to you today about some interesting things that you can do to more effectively defend your network with some of the tools and techniques that are made available to you by software-defined networking. And so, yeah, let's go ahead and get started. I'm going to start by giving a brief overview of what Sdn is and why I think it is interesting and useful from a defensive standpoint. There's sort of the capabilities that it brings for you. I'm going to talk to you about some of the different tools that you can use to monitor that and keep tabs of what's going on in your network. And then I'm going to show you some pretty unique and novel ways that my team has been researching to use those capabilities to more effectively defend your network. So with that being said, basically, if you're not familiar with it, software-defined networking is essentially just the idea that instead of treating the different infrastructure devices on your network as these special purpose unique snowflakes, they're just general purpose computers that you've given a special job. So in the same way that you would assign a particular server the role of being, say, a mail server or an AD controller, what you can do is basically a switch is just a computer that has the job of switching traffic throughout the network. Architecturally, this actually doesn't change your network terribly significantly. The only real difference that you can see in this diagram is this green controller box here. And what that's effectively doing is you're letting the switch offshore all of the like heavy thinking into this controller machine so that it can just do its job of switching traffic around. And the controller gets to handle things like dealing with the topology of the network and so forth. And then typically this also is conflated with the separation of the control and data plane. So some of the reasons that I think that this is a really good match for security, and also my team does some work with this with machine learning, which we'll talk about here shortly. But, you know, one, I, like many of you, am an engineer by trade. And so, you know, if I want to talk to a piece of software and make it do something for me, my first thought is like, what is the API? I can go tell it to do that. Through the API, just make an API call, and you know, it's a very native workflow. So it lets you do that. You can start doing things like configuring your network programmatically in response to events that are happening on the network. So you get central management. This is one of my favorites. You can version control your configuration. I recently had an issue where I broke my DNS box on my internal machine, right? And I had to go through and re-image a bunch of stuff. But I re-imaged it. I pulled my configuration back down from GitHub, put the files in the appropriate places, and I was back up and running again in, I'd say 20 to 30 minutes. It wasn't a lot of downtime. So that's really cool. And then also, because the controller has this holistic high-level view of the network, you can start collecting data really easily, right? And you can do it anywhere from any perspective. You don't need taps. You don't need, you know, any kind of weird hardware. You don't have to start remoting into different machines to see things. You can just grab it from that controller. Very handy. So the controller that I'm going to be using for the purposes of today's demo is called Faucet. It's an open source controller. It's compatible with any OpenFlow v3 compatible switch, which crucially means that it's compatible with Open vSwitch. the things that I'm going to be talking about today are things that I would like people to try. I would like people to try and put into practice. And so the fact that there's a virtual switch option out there so that you can go, and try these things without needing to invest in hardware is very important to me, at least. I think that's like, I hate the idea of people being priced out of learning things or embracing good security practices. So some of the important features that we're going to make use of in this, ACLs and VLANs, which hopefully everybody is already familiar with. If you're not, I'm happy to talk about it, but I don't want to belabor it here. I don't want to lose people. And then we're going to be talking about something called coprocessing, which to the best of my knowledge is a technique that's unique to Faucet. And it's really going to be the meat of the demo that I'm doing later. So we're going to talk about that in quite a bit of detail here in a bit. The way you actually go about configuring Faucet and the ACLs that you want to use, you just write good old fashioned YAML files. I know everybody loves YAML. I do. Or maybe that's Stockholm syndrome. It's hard to tell. But the great thing about it, it's human readable. You can diff it. I've definitely had scenarios where I did something to my network configuration and I wasn't sure what, and being able to just go in and say, what changed between here and here was very, very helpful. And again, you can version control it. So another cool thing about like the version control thing, in the office of the company that I work at, we actually have a big internal Faucet deployment. And we also have an internal version control system. It's GitLab, right? And so what you can literally do is if you want to say add a device to the network or remove it from the network, you just go into this GitLab instance and you make a pull request against the network configuration. So then somebody from the IT team goes through, they review that, say, thumbs up, thumbs down. And if they approve your pull request, that kicks off this CI/CD pipeline that pushes all that config out to the controllers, and the network is just ready to go. So you can just entirely self-service add these endpoints. Well, mostly self-service, right? Somebody's got to review it, but it's just really easy. It's a really slick system. Those guys were very clever when I thought it up. So under the hood, what Faucet is doing is it's converting that YAML file into these open flow rules, open flow flows. And this is kind of an example of what an open flow looks like. That's from the flow table. They're, as you can see, very hard to read, not terribly intelligible. And so I like to think of the relationship here. What Faucet is doing for us is very similar to what something like UFW is doing for IP tables, right? You can go in and you can manually write those IP tables rules. And you can see I've got an example of a very, very simple one down there. But it's way easier to just go into UFW and say, deny from block. So it's just giving you a cleaner, more human-friendly syntax, among other things, but from the standpoint of open flow flows. So another tool that's going to be in play today, and there are a few of these, I apologize, so bear with me, is a tool that the team I'm part of wrote called Poseidon. And what Poseidon is it's an open source kit to monitor your network using Sdn. Excuse me. And what it basically does is Poseidon interfaces with that controller and uses that interface to gather traffic to run through this analysis pipeline. And we're basically trying to answer three questions. What is actually on my network? What is it doing there? And do I care enough to do something about it? The way that you go about doing that in an Sdn is you have the ability to mirror traffic. So what happens is that you will tell the controller, I want to mirror traffic from this location to this location. Poseidon, then we record that as a PCAP. So I know some of you who are probably more privacy or liability conscious will be glad to know that the absolute first thing we do is just dump the payloads. We don't want to see it. We don't want to know anything about it. We assume that those are going to be encrypted, and so they're going to be junk from an analysis standpoint anyway. We go through a bunch of other pre-processing too, where we like split it into conversations and do some different things with it. And then we pass it off to this configurable suite of analysis tools that we've built up. I'll talk about a couple of those here in a second. And then the basic idea is, based on the output of those tools, we can do one of three things. Technically four. I should have put the fourth on here. So you can say, I don't really think I have a handle on what's going on with this thing. I want to keep watching it. That's continued mirroring, right? You can say, something bad is going on here. I don't like it. I want to wall this thing off from my network. That's the quarantine option. You can apply an arbitrary ACL, and we've got like a configurable rules engine where you can say, based on these metrics at these thresholds, this is the ACL I want to apply. And then the fourth thing, which is tacit, is like, everything's fine as you were, carry on. So a couple of the things that we're using under the hood there, we're using POF to do OS fingerprinting. We're using Network ML, which is a machine learning model that our team has developed in-house that is focused on the idea of doing device role identification, sort of with the thought being that, let's suppose you have this device and, 2 weeks ago, it was behaving like a business user's workstation. And last week, it was behaving like a business user's workstation. And yesterday, it was behaving like a business user's workstation. But today, for some reason, it's starting to act like an FTP server. You might want to go investigate like what prompted that change in behavior. Is that something that needs to be investigated? Is that something that you need to look into? And then we also ship with some Grafana dashboards and Prometheus metrics. Again, the basic idea being that those are pretty standard tools that people are used to using, just to make the data more visible, make it easier to present it out to other people. One of the things that, at least in our group, we've seen and kind of thought a lot about is the fact that, network facing folks are very used to working in terminals and kind of trust that. But when we try and take the information that we find there out to other people, it becomes very hard to communicate because, they see that black and green and they just kind of, their eyes glaze over and they tune out. The look my wife gives me when I start talking about stuff. So coprocessing. We're getting into sort of the meat of what's going on here. And coprocessing, again, as far as I know, is a technique that's unique to the Faucet controller. But what it lets you do is use an ACL to say, I want to pull traffic out of the general traffic stream, and I want to pass it off to this external entity to be processed. Okay. The coprocessor can do whatever it would like with that traffic. It is responsible for that traffic. And one of the cool things about this is, you can have coprocessed and ordinary traffic just side by side. It boils down to the granularity of the ACL you write. So that you can use it for a lot of different things depending on your use case. So for instance, you might for some reason want to say, I only want to co-process traffic between this IP address and this IP address on this particular port. And then it will just leave everything else, even between those same two machines, alone. Or you can say, I want to grab everything on this port across the network. My buddy Josh, one of the things that he does with this is he just scoops up all traffic on TCP and UDP 53 and co-processes it through his DNS server, right? So what he's done there is he's mitigated any misconfigurations. So if a device has like a hard-coded DNS server it wants to use, or somebody sets their DNS wrong, it doesn't matter. It still goes through his DNS server and gets a DNS response. And as a side effect of that, it looks like he has really, really fast ping times to like stuff like 8.8.8 and 1.1.1.1. Like the backbone of the internet is, in his server closet. The coprocessed packets are, at least to my knowledge, indistinguishable. Maybe somebody smarter than me can figure out a way to tell. I don't know. Oh, thanks. Thanks for that, PowerPoint. Okay, so some more crucial details about this for the purposes of what we're talking about today. The way you actually do this is in that Faucet config file I showed you earlier. You're going to designate a switch port as a coprocessor port. It's going to get marked output only, so it's not going to show up on different types of scans and things. But the coprocessor is now totally responsible for dealing with those packets, right? So you can do whatever you'd like with them. You can forward them on to where they're supposed to go. You can drop them. You can have the coprocessor respond. You can modify them on the way to their destination or on the way back from their No, not on the way back. That would have to go through something else. Sorry. But you can modify them in flight. Moving on. So now if you were paying attention on the last slide, you noticed that I said that happened at the switch port level. And one of the problems that we bumped into when we were doing this is, particularly if you're using a physical switch, if you want to coprocess multiple things, that becomes a very real estate intensive type of thing. Okay. And so we created this tool called Pipette. And the reason Exhibit is over here is because literally the way this works is we took your big SDN and we mounted a tiny little SDN in the back of the headrest. And what that smaller SDN does is it acts as a network for just your coprocessed services. So under the hood, there's just an OVS bridge that we're sending stuff to on different ports so that you can have multiple coprocessing services going at the same time on a single physical switch port if you're using a physical switch. One of the two things that I think are cool about it. One, if you're interested in that sort of thing, if you've made the decision that based on your use case, you want to see what's going on, it can be configured to do full capture through that coprocessor. So you have a PCAP of everything that goes in and comes out. And then again, because we're engineers and we're lazy, all of that stuff can be controlled via an API, right? You can start things, stop things, change configuration, etc. Last tool, because I feels like I've just been rambling through this list, and I apologize for that. Thank you guys for bearing with me on this. The last one is this tool that we built called DoveSnap. And what DoveSnap does, and this is really cool, and I'm just scratching the surface here of things you could use this for, but it lets you merge a physical and a virtual network. You can basically have a physical switch and a virtual switch acting as sort of the same switch from the standpoint of anything interfacing with them. And the other thing that's cool is, I mentioned again, mirroring in the SDN context. We cascade that through like the entire thing. We create this, we call it a mirror river, so that you have full visibility of the traffic flowing through your network, which I at least think is really impressive, and it lets you do some really fun things. So now we're going to go on to my demo. So first off, if we could all just, as a moment, agree, I'm going to try and do a live demo here. I make zero guarantees. If things don't quite pan out, I do have a video of it, but like, if anybody asks, it went off flawlessly and I am a wizard. And in return, if anybody asks me about a demo that you did, I agree that it went off perfectly and you are magnificent. Everybody on board with that? Awesome. So in this demo, I'm going to show you two different ways to use coprocessing. The first one is this deception slash active defense use case. And basically the way it's going to work is I've got this hypothetical, well, it's not hypothetical, it's a real network. I set it up. It's got two web servers. One of them is meant to be this sort of data-backed corporate intranet type of site, something that you would go in and look at, within your enterprise if you wanted to track like metrics or something of that nature. And the other one is meant to be an approximation of like some kind of demo server, right? So something that people are in the process of building out. They want to get feedback. They want to share it with people, but it's probably not quite ready for prime time. So we're going to have these two endpoints, and we're going to use coprocessing to sort of deceive the attacker and kind of try and lead them through the network, right? We're going to try and give them some decision points, but make it easier to go sort of one direction than the other, so that we can kind of coax them into places that we want and give them reactions that maybe aren't what they would expect or hope for. So just to kind of forestall the question that I inevitably get when I start talking about this, how am I differentiating what I'm talking about here from a honeypot? A couple sort of important things, to me at least. A honeypot is just a single purpose thing, right? You'll have an SSH honeypot or an FTP honeypot or something of that nature. So this isn't like that. It doesn't have the same signatures, that sort of thing. Also, and I can't stress this enough, coprocessing is not just a deceptive technology, right? So a honeypot is always a deceptive thing. Coprocessing isn't necessarily deceptive. I'm using it to create a deceptive environment, but as in my early example where Josh uses it to mitigate DNS misconfigurations, there are other usages. I'm just picking on some here. The other thing that I think makes this different from a honeypot, but cool for deception, is you can have sort of deceptive services and live services side by side on the same endpoint. So, for instance, a very common pattern, you have an HTTP server of some sort, and then you'll have SSH alongside of it that people use to manage that. Well, totally possible to have a live HTTP server and then co-process the SSH on that same server, right? So that if somebody comes in and they feel like they found credentials or something, they're not playing with what they think that they're playing with. So sort of the other way that I'm going to use this is to protect a database. This is a use case that's actually very near and dear to my heart. I started my career as a database admin for like a retail company. And so sort of the trials and tribulations that people who have to manage production databases live with I've got scars from those things. And so, if I can give back and help them and make their lives easier. So with that being said, we're going to attempt to launch into the demo here. This is what we want the attacker to think the network looks like. Maybe this is what the network looks like. I would be hesitant to trust me if I were you. I've already told you I'm going to try and deceive you. So these are the things that they will see. With the exception of this OpenFlow controller, that's not going to be visible. That's just there for the sake of completeness, and quite frankly, because I borrowed this from a different diagram. So, and what we're actually going to do in this demo here is, I'm going to put on my bad guy hat for a minute. We're going to try and access these web servers, and we're going to try and get into one. Use that as a jumping off point to explore the network further, see if we can find some useful information with the ultimate goal of, defacing or polluting the data, back-ending that data-backed intranet site that I alluded to earlier. So with that being said, all right. So that's okay. Awesome. Good. Don't do that to me, computer. So to start with, I'm giving you sort of the legitimate user view of the world here, right? Well, did that twice. So this is the data-backed intranet site that I was talking about, right? We want to try and get behind this and pollute this data or deface it, whatever you want to call that. And then this is meant to be the secret demo server. If you're curious, the reason the image is here is because in an earlier version of this demo, I cast myself as John Candy in the excellent film Canadian Bacon. That was a premise that was much less understandable to people than I thought it would be. Apparently not a hugely popular movie. You live, you learn. But I like the picture. So now I'm going to put on my bad guy hat. All right. And I'm going to do a couple of things. So first off, you can see as the bad guy, you see the same data that the legitimate user does. That is an artifact of the way I've configured this. But you also see a very, very different view of that demo server than the regular user does. And that's very deliberate. That's very important. We're going to leverage that here, right? So, just kind of looking at these two things. Okay, so first off, let me pull up my terminal window just for, kind of the sake of honesty here. I ran this earlier, so I didn't have to waste a bunch of time doing it, but this is a very basic Nmap scan, kind of showing you what is going on here. You can see the demo server and the intranet server here, running Apache, etc. And then there's also the database site back there. I probably scroll that away. So one thing that I'm going to do here, I'm just going to start running a TCP dump on this. Don't worry about this a lot for a second, but it will become material later. Just bear with me. Okay, cool. And that, just for the record, is running on the site behind that, the demo site, right? That's the server that I'm SSH'd into. So I'm going to go over here. I've got, yeah. Okay, so, as an attacker, I've got my bad guy hat on now. Right. I tried to do this once where I had a literal hat so that you could visibly tell, but that got really confusing for me. So we go through this, and if you look kind of up here at this in this pattern, you'll see that it looks like somebody has used a very, very bad PHP include pattern that is maybe vulnerable to some types of file includes. So let's see if that is indeed the case. And yes, it looks like they are indeed vulnerable to a local file include. Let's see if RFI works. All right. And RFI does indeed work. Okay, we're running as www data. That makes sense. We knew from our Nmap scan that we are dealing with Apache, right? So let's try looking at the standard Apache directory here. And I'm going to go one thing deeper just in the interest of time. But, oh, of course not. Sorry, folks, I cannot talk and type at the same time. My brain considers that to be some sort of stream crossing operation, and it refuses to let me do it. And I do apologize, but there we are. Okay, so we're just going to see what's here in this directory. And the first thing that jumps out to me is you've got this .git subdirectory, right? Which tells us that this came from some sort of version control system, and we can start asking questions about that, right? So we can see we've got a Git server. I don't want to belabor and waste a bunch of time on like how you would go about it, but there are obviously ways to go out finding what's there and enumerating that sort of stuff so that you can take advantage of it as an attacker. I'm going to take the lazy man's way out and just kind of hand wave that. And I'm going to say we magically figured out that there is this other repo on there that we might have access to that, as you can see from the name here, purports to be the production database server. So we're going to clone that, and we are going to go in. And again, you can see we've got a couple of interesting things. So let's start by looking at this start.sh server. All right, so this actually tells us a lot, right? If we didn't have it from our Nmap scan, we've got an IP address and a port, we've got a password, and we've got sort of this Docker command here. And what this Docker command tells us is that that setup directory that we're looking at up here gets mapped into docker-entry-point-initdb.d, which for those of you not familiar with Docker, or sorry, MySQL running in a Docker container, basically means that when we run this, that setup directory gets pushed into that projected essentially into that directory, and MySQL will run whatever scripts are in that directory when it starts. So let's see what's in that directory. Oh, what luck. There's just one SQL script. So let's go ahead and look at that as well. And again, the typing. Okay, so here's the last of the stuff that we needed, right? We've got the password again. It matches. We've got a username. We can see the privileges. There are way more of them than it needs. We've got some schema information, and we've got this data, which, you know, meshes with what we're seeing here, right? So again, you know, going back to what I was saying earlier, taking my bad guy hat off for a moment, going back to what I was saying earlier, right? We've got a decision to make here of sorts. Do we choose to act on this data or not? But it's a very tempting target as an attacker, right? So again, we're going to want to follow this chain, kind of almost have to see where it leads. So if we go ahead and follow that where it goes, so we already know from that script that we're using RealDB. I was feeling exceptionally lazy today. Well, not exceptionally lazy, exceptionally uncreative. Let's say that. I couldn't think of a good database name. So we run show tables here. We can see we've got a table. I'm going to start do copy and pasting here because, like, I wasted a bunch of time scripting out all these commands I wanted to run, and I'm sitting here typing things, even though I know I can't type and talk at the same time. Who am I trying to kid? So, and again, we see the data that matches conveniently right there behind. If you can read through that, I can't. I'm nearly blind. So let's go ahead and you know, take this to our logical conclusion. Yeah. All right, so we've updated 4 rows. Let's just double check that data. I didn't plan this way, but this is real pwned is pretty funny. Somebody wants pwned. Pretty happy with how that came out. Okay, so like at this point, as an attacker, you know, we're starting to do our happy dance. We're starting to feel like we've won. Pardon me for a moment. All right. So like the last thing we kind of have to do before we break out the old mission accomplished banner is just go back over here, refresh this guy, and wait, nothing has changed. And I can do this all day. Nothing has changed. So now, again, remember, we had these different decision points. Do I go after this demo server? I get this information from Git. Do trust this information? Following it, what does it mean? We have to go back and rethink all of those things. Okay, so one last thing before I go back and sort of explain how all of this happened is, remember when we very first started, first thing I did, right, is I went over here to this particular window and I told you I was going to run TCP dump and that I was running it on the host that was hosting that machine. Okay. There are no entries in this TCP dump. There are no entries in this TCP dump. When I put my bad guy hat on and I thought I was talking to that server, I was never talking to that server. And the proof of that, lest you are tempted to be skeptical of me, as you should be, because once again, I told you up front that, I was going to try and deceive you. There, when I refresh over here, you can see I'm getting these entries. So that being said, let's go back and we'll talk about how that happened, because I'm actually under the hood playing some very cool tricks, at least in my opinion. All right. So first off, this is what the network actually looks like. I told you that I wasn't being totally upfront. If you did trust me, it was foolish of you. You should never have trusted me. So as you can see, we've got this OVS bridge here. It's being run by Pipette, and I've got the decoy demo server and a different database server here. And we're going to talk through sort of the ramifications of both of those and the way they get used here, because they're actually two very different things. So the way I did this is, again, two different demo servers, right? The legitimate user gets to interact with this. The attacker never does. The attacker is talking to something else entirely, okay? And the thing that they're talking to exists over here, hanging off of this OVS bridge. This is the place they get to go when they think they're going to talk to this, right? I've run through a couple of the differences here, but I think I've kind of talked through that a bit anyhow. So I mean, it seems like it's a whole other web server. It should be obvious that you're running two web servers, but because of the way this works, it's actually really not. One, as I said earlier, that switch port is output only, so it doesn't participate in things like ARP traffic or any kind of broadcasts that go on the network. The other thing is, think about the way a network scan works, right? When you're running Nmap, or if you run something through Bash or Python or however you want to do your network scans, you have to talk to that machine on that port. That scan traffic also goes through the coprocessor, right? When I ran the Nmap scan, it presented as an Apache HTTP server. And that's because I'm running an Apache HTTP server on the coprocessor. In point of fact, if you were to go back and look at the information coming off of the legitimate web server, you'd see under the hood that I'm running an Nginx box, which is going to present completely differently. So right there, I mean, I've presented two wildly differing views of the world from the same box, apparently from the same box. Which are really, really powerful from a deception standpoint. The databases actually work entirely differently. So what I did with the database, almost the exact opposite thing, right? I made the command decision that, hey, we've got this server that's serving up data, and because of its job, it needs to talk to the database. So I've set the ACL up so that only things that need to talk to the database can talk to the real database, right? Everybody else goes to the fake database server. So a couple of cool things about this. Well, my favorite thing about this, I think it's super cool. Okay, so when I was a DBA, every time I had a job where I was in charge of managing a database of any sort, the thing that I absolutely, positively, 100% lived in fear of was sort of like the whoops update, right? And we've all done it. Many of us have had it happen to us, right? But it happens a ton of different ways. I was logged into the wrong thing. I had the wrong connection string. I was misconfigured. It happens, but it wrecks somebody's day. What I've done here actually stacks the odds massively, massively in your favor, because not only to do the accidental update, now somebody not only has to do the wrong thing, but they have to do the wrong thing from the exact right spot in the network, right? So we can really, really make our database much more secure, much more walled off. And we get this nice little deception ploy off to the side for free, well, for the low, low price of one extra Docker container, right? So, I mean, I'm sure you guys have questions about the effectiveness of this. So I'm going to give you just kind of a couple of data points about that. Those are logical questions to ask. If you look here, this is, an IP listing coming out of the fake database server, right? And you can see it's got its address and MAC here. This is a TCP dump running from on that server. And you can see that these MAC addresses match up. And so what we're actually doing under the hood is we're doing NAT at L2. So you've got a packet. It's got its source IP and source MAC. It comes into the coprocessor. The coprocessor grabs that source IP and source MAC, stores them off to the side, okay? Gives them it's got its destination IP and destination MAC, right? Where it's going. Okay, so the pipette grabs the destination IP, destination MAC, sticks them off to the side, replaces them with the appropriate destination IP and destination MAC for where it should be going in the coprocessed network. The coprocessor does its thing, sends its response back out. Pipette grabs that response, pulls its source IP and source MAC off, replaces them with the ones it got coming in, and sends it back to the original source, right? So we're swapping those in and out at line speed, which is frankly incredible that we can manage to do it. But as sort of one anecdotal data point, our team, actually my buddies Charlie and Josh, we're running our internal blue team. We're doing some red team, blue team stuff on some open source 5G things for an internal project that we're doing. And I was the red team. And I knew, right? I knew ahead of time that this was a thing that they could do and knew how to do, that they wanted to do, and that they were going to actively try to do to, quite frankly, embarrass me, because, they're my buddies. That's what they do. Plus, we're competitive, right? Like, I know at the end of the day, we're all on the same team, but there's still that, like, I kind of want to win thing. It happens. And they were able to fool me with it, even though I was looking for it every step of the way. Like, I was trying to watch for it. I knew it was coming, and they still got me. And I was like happy and mad at the same time, because it was like, yes, it works, but also it's like, God, they win, crap, So that was fun. So just kind of to recap, what we did here with software-defined networking and Poseidon and this whole raft of other tools here, we were able to configure a network, check the behavior on it in real time, react to that behavior, and then implement these really unusual and sophisticated deceptive measures and protective measures without a whole lot of overhead. So that being said, I would be remiss, if I didn't kind of shout out all the different open source projects that I made use of to make this happen. There's a lot of really great people doing a lot of really great work that makes this stuff possible. I also have to give, huge thanks to my teammates, Charlie Lewis and Josh Bailey. You've heard me mention them a couple of times already. They're fantastic engineers. fantastic people. I cannot speak highly enough of them. And so, with that being said, first off, thank all of you for coming. I know you have a lot of other options and places that you could be. You could be over in the other channel listening to Alyssa Miller. So just let me know how much my mom paid you, so that I would feel good about myself. So I know how guilty to feel next time I visit her. But yeah, if anybody has any questions. Let's see if I can pull up the Discord thing over here to see if there are any questions. Okay, so um, let's see. The one question I'm seeing is, what was the hardest thing for me to learn in regards to SDN? So I would say that debugging SDN is kind of a unique and interesting thing. That's probably a little different than an ordinary network. Now, admittedly, my experience with non-software defined networks is more limited, but basically, like, debugging those is you plug things in, you trace some cables, you run some TCP dumps, some trace routes, some pings. With a software-defined networking, debugging becomes more complicated because you've added like this extra layer of abstraction, right? You've got to, is my switch talking to my controller correctly? Is my configuration correct? Is that being translated into flow table entries the way that I think it is? It's just a more drawn out debugging loop, in my opinion. So that's probably what I would say. Any other questions? All right, I see somebody at least loves YAML. Okay. All right. Okay, again, thank you guys for taking the time to come and listen. And if you have any questions that didn't make it into here, or you think of questions later, feel free to look me up on Discord. And I probably could go back and like first slide here somewhere. I have my Discord username. So yeah, this bird wainer, that's me here on Discord and on Twitter. If you think of questions about this later, or you want to talk about SDN. Thank you guys.